Hello everyone. So in this video, we will learn how to deploy a microservice on an ECS cluster and explore best practices for designing a GitHub repository to create AWS infrastructure. We will also discuss how to decide which AWS resource should be shared and which should be service specific, ensuring that our infrastructure as code is organized and scalable. Let's get started. So to start with designing your infrastructure and creating a GitHub repository for your Terraform infrastructure, the main important part is we need to identify what all AWS infrastructure is required. So as you can see in this diagram, we need VPC, ALB, ECS cluster, cloud map, and all other resources which are specific for ECS cluster. So this is the required infrastructure that is needed to deploy any application on the ECS cluster. Now the next part, we need to identify which all can be shared and which all resources needs to be service specific. So let's get started with the VPC. So if we talk about VPC part, we can just go with a single VPC, right? A single VPC is created per environment. We really don't need to create a different VPCs for each of the microservices. We'll just go with a single VPC, right? The second, ECS cluster. So a single ECS cluster is created per environment. Like we create dev, prod to host all the microservices. As such, there is no direct cost of creating multiple clusters, but it is considered as a best practice that manage one per environment for the simplicity and scalability. The third, ALB. So single ALB, application load balancer per environment, which is very important because it reduces the cost significantly. And by using the routing, path-based routing traffic, we can just route it to different microservices. So there is never ever a requirement to create ALB for multiple microservices. Just create one ALB per environment. Cloud map. So cloud map is basically used for the service discovery, and it is set also as per the environment. So it's set up per environment, but the name of this cloud map is same across all the environments because it is like a friendly DNS name for your microservices so that they can communicate with each other. So we will just have a single cloud namespace name per environment. So now you have decided what all shared infrastructure you need. Now let's talk about how we can design it, right? So this shared infrastructure, this is not related to your microservices, right? So we can actually separate out the shared infrastructure deployment and your microservice infrastructure deployment. Now I will explain how I have designed this GitHub repository. So here you can see that I have created this shared AWS infrastructure, and under that I have created a separate Terraform file for each of the resources. So just go with alb.tf file. Here you can see that I am creating first public load balancer, and I wanted it to be externally accessible, so made it internal as false. And here you can see that I'm using the variables for all the naming of the resources so that this same code can be used across all the environments. Like if I will run it for dev, it would be dev hyphen alb. If I would run for prod, it would be prod hyphen alb. So I am using the variables for all the naming conventions wherever it makes sense. So this is the code for creating the AWS ALB, and then you need a security group. So there is one external security group, which means that this load balancer can be accessible outside the VPC. So from where it can access. So here you can provide all the IPs, or if you want to restrict it with some VPN IPs or anything, or if you want to have it accessible by everyone, you can provide the CIDR block in that range. I will show you how I am providing it in this example. And this is the internal security group, which is for the communication between services within the VPC. So this allows all the traffic within VPC so that all services can communicate with each other. So this is like an internal security group. Now the next resource, we have a cloud map, which is a very simple resource where you have to just provide the cloud map name, and that would be your DNS friendly name for your microservices, and which will be used for any services to communicate with each other. I will also show you how we are using it, and in this example what name, what value we are providing, and the VPC ID. So this is how you create any cloud map resource. Then the ECS cluster. So here I'm creating the ECS cluster, and again for the name, here you can see that I am using the environment variables and then capacity provider. So in this example, I am using Fargate. You can use the EC2 options also, but for this particular video, I will be using the Fargate option. And then the provider configuration. So here you can see that I'm using this AWS provider for creating all the AWS resources and the default tagging. So here you can see that you can provide the tag. This is like a default tags at the provider level for all your resources, so that this tag will be applied to all the resources which was created using this provider. So this is very helpful managing and maintaining your tags across and across all infrastructure. And this is simple variable files where you provide the all the variables which are required. So now for the, so this is all your infrastructure you have created. Now I want to deploy it for dev environment. So what you have to do, you have to go to your dev folder. So basically you can create multiple folders based on the requirement or based on how many environments you have. And here you have a backend.tfr where you'll provide the backend configuration for your Terraform state file. So this is like region you provide, the bucket name. So in my AWS account, this bucket exists. So I am using that, and the key file. So this would be your object that will be created inside that S3 bucket, which will store all the Terraform state configuration for all your resources. And this is the Terraform TF bar. So this is where you provide any environment specific variables values. So environment, right? So you want it to be dev, allow IP. So I showed you in the ALB security group. So here I am using this particular allow everyone. You have an option to change it based on your requirement. And here I am providing the VPC ID also. In my AWS account, the VPC ID was already created. So I am just using it and providing it as part of my variable files. If you have to create another environment like prod, you can just follow the similar structure and just change the values based on that environment. So this is how your shared infrastructure is designed. So here you can see that when we have a deployment, it will do the deployment for all the resources in just one go. There is no other configuration required, and there is no other settings that you have to do with your GitHub workflow. Once that workflow run, it will just create this whole infrastructure for that particular environment. And it is very scalable. Whenever you have to add a new account or new environment, just add the new folder and that's it. So now we'll see how my GitHub workflow is designed for this particular deployment. So I have this deploy.yaml file where it's simple. Workflow dispatch means if I wanted to run it manually, then you have an option for that. And it will get triggered whenever there is a push event happens on the master branch. And then this is where you can see that I have put the matrix. I'm using the matrix, so that currently it is just for dev. As you have more, you can just add more matrix there. Currently it is just doing for the dev, and the only thing that is required is AWS credentials. So here you can see that I have provided the secrets, and this I have put in the settings. So here if you go in settings, there is a secrets for all of your repositories, and you can just create a new repository secret there. So that is the only information which is required for your infrastructure to get deployed on your AWS account. And after that, you have a simple Terraform init command, and here you can say this is also parameterized. So based on the environment, it will get dev, prod, and it will do the deployment. And then it's a Terraform plan. And if it is a master branch, it will do the apply. So basically apply the changes. Okay, so now I can show you how the workflow runs. So here I have the last deployment that I ran. I just wanted to show you how does that look like. So currently there was no changes, so it was not showing anything. But if I do the last one, so here you can see Terraform plan, and we have ECS cluster, we have load balancer, and we have all the security groups listener rules. So here you can see that it is creating all the resources, and how much time it takes. It is just taking 3 minutes to deploy that particular resources on the AWS account. Now let me show you how it has created all the infrastructure on the AWS side. So if you go to EC2, I'm just showing you the load balancer. So if I go to my load balancer and if I click on this dev ALB, you can see that it has created with that particular name. And the second thing that I wanted to show, the tags. So here you can see that all the tags are also gets created successfully. And the second part is the cloud map. So let me just show you how the cloud map looks like. So this is where you see that it has created the namespace with the name corp, because we are using the variable name as corp. And in all my microservices code, this is the URL that I will be using to communicate with the other microservices. So this is where we have deployed all the shared infrastructure for dev environment in one AWS. Now we have designed our repositories, right? So this approach, if you can relate, it is related to the monolithic setup, where all your AWS resources are tied to a single Terraform state files and deployed simultaneously, right? So there are key benefits for this approach also. Like all your infrastructure will be deployed at the same time, which simplify the setup process. Like today, if I have to create this whole infrastructure into any of the AWS account, it is very simple. It is just 1 or 2 minutes of job. It's very quick setup. The only thing that you need is like AWS secret keys. You can use it and deploy it efficiently. So this approach is highly efficient for your small applications where you have a fewer resources. So everything you can manage it in one place. The drawback for this approach, monolithic nature. So if there is an issue with one resource, like you have an issue with the ALB, it can impact your entire deployment. This can be problematic when you have a number of resources grows, right? Scalability concerns for larger setups, like you are creating the RDS also. So this monolithic approach can become cumbersome, because if you have an issue with the RDS, it will affect the entire infrastructure. Although the RDS has no direct relation with the ALB, but it will create or it will have an impact on those resources as well. So that is the drawback for this particular approach. But for the simple approach, for the simple application, this looks okay and it works fine. So the alternative approach for mitigate the drawbacks, so we follow a modular approach also. What does that mean? We'll create a separate folders for all of the resources and create a different Terraform state files for each of them. So this way your resources are independent of each others, and issue with one will no impact with the other ones. So in summary, monolithic approach best for small applications with fewer resources, quick and easy setup. Modular approach better for larger applications with more complex infrastructure, because it provides isolation and reduce the risk of widespread impact from individual resource issues. So now let's explore service specific resources. So we have identified that ECS services, ECS task definition, IAM roles, all the resources which are related to the ECS service are unique across all microservices, right? And we need to create all of them for all your microservices, but the functionality remains same. Like to create an ECS service, to create a ECS task definition, we can actually create a reusable Terraform resource or Terraform modules and just call those modules and pass the value according to your microservices, right? So this would be your service specific repository. Now how we will design it? So in my this example we have three microservices, so we are going with a monorepo setup for the deployment. So now let me show you how that repository is designed. So here you can see that I have three services: hello service, hello word client, and word service. So you can have multiple services as well. I'm taking an example with three. So this is three services I have. And then I have created the Terraform reusable modules, which is called modules. And I have put the name as ECS Fargate service. So here it will have a code to create a ECS service, to create a ECS task definition, IAM roles, CloudWatch, security groups, and the target group. Whenever any microservice call this module, it will create all the resources which are required to deploy any microservice on the ECS cluster. So let me just show you what is in like ecs.tf. So here you can see we are first creating the ECS service, and all the names are passed through the variables so that it is customizable. And all your microservices, like if you have 20 or 30 microservices, all can use this module by passing the value. And here you can see that we have a proper load balancer configuration. This is the service registry, which is like your cloud map namespace and your network configuration. And the second that is important, the target group. So where you have a target group, you have all health check configured there, and this listener rules like based on, so we are using the same ALB for all the microservices. And how that will work, you will have a listener rules, and based on the path pattern, your request will route to that particular target group. So your microservice, particular one microservice will go to one target group, another microservice will go to another target group. So this is how our module is designed. Now I'll just take example of one of the service, which is called hello world client. All of three is set up in a similar way. I will just take an example of one. So here you can see this is simple Java application with all the Maven files and the source files. And then we have a Terraform. And in that, again, it's a similar structure that we did with the shared infrastructure. If you have multiple environments, you'll create these folders and pass the environment specific values as needed. And in main.tf, you will see that I am calling this module like this and passing all the values from here like this. So here you can see that I'm passing all the ECS cluster, load balancer name, and log group, ECR. So from where actually the image needs to pulled, the port and the path pattern, everything. And the most important part here is the container version. So when we are deploying any ECS service, how we are actually creating the new task definition. So we are always using the container version, which is actually your GitHub SHA of your latest deployment. I mean, whatever you have committed, the GitHub SHA, we are using it. And that is also a best practice, that do not use always latest tag. So we are always tagging our ECR images with the container version, and which is actually the GitHub SHA. So after you call this module, it will create your service. So here I can provide you, this is normal variable files. And if we go to dev and check what all values we are passing, so here you can see we are passing environment, VPC ID, and that's it, cloud map namespace. That's the only thing we are passing it. And this is the same code that I have for all the three services. And the one thing that I wanted to show here, so how we are using how we are using those internal service communication. So here you can see that http hello.corp/hello, http word.corp/hello. So this corp is your CloudNet namespace that you have created, and this what I have put in my service name, so that the URL would be like this, and it can be used across all the environments. When it is a production, the URL will remain same because it would be in a different VPCs, and the communication will still happen properly. So that is one thing that's I wanted to show here. So this is how you design this, and then let's go to your GitHub workflow. So I have created the workflow file for all the three microservices, and it also follows the same pattern that we had for the shared infrastructure. Here you have a path pattern because we have a three microservices. So based on which folder has changed, it will get triggered. This is your working directory you need to set from where you have to run the Terraform. And so this contains your CI also. So basically this is a Java project built with Maven, so you are building it, and then you upload artifacts. So this is the action of the GitHub. So you upload it with the name app.jar, and then you log into public ECR. So this is like my public this is the this is the code to authenticate with the public ECR, and then you download the artifact. And at last you are pushing your you are pushing your image to the ECR repository, and here you can see that we are passing the GitHub SHA like image tag, and this is your container version. Here I will show you how we are doing this, and this is your Terraform deployment. And here, if you have to pass any GitHub secrets or any variables from your GitHub workflow to Terraform, you have to append that with TF. You have to use TF underscore var underscore whatever your name of the variable, and provide the value. And after that, it's simple Terraform init plan and apply. So this is how we design this workflow. And now I just wanted to show, if I do just this deployment again for any of these services, I have put the workflow dispatch. So I just run the workflow, and it will just run. So let me just run for all of them, and then I will show you how it will look like. So now you can see all of them are building separately, and all of them will build the project using Maven action, and push the Docker image to the ECR repositories, and then deploy it on the ECS cluster. So let me show you how it looks like. So let's go there and search for the ECR. First, I wanted to show how that ECR repo will look like. So here you can see that this is one of my example, and this is what I was talking about, that it is your GitHub SHA, and this is your version of the application also. And when you go to the ECS cluster, you will see that it is using this particular image version for the deployment. And then let me go to EC2 and go to load balancer, and here you will see that we have created four rules. The four rules I have created: slash hello goes to this particular, slash word goes to this path pattern client tab, and if nothing matches you will get 200 fixed response content. So this is how your listener rules also created successfully. And when your deployment starts, then how it will look like, let me just show you. Yeah, so it already started. So here you can see that it already started with this, and if I go there, it's started, it is running, and once it's up, we should be able to access the application using the load balancer URL. So let me just go there, EC2, and go to load balancer, and click on your DNS name, and see that you are getting this particular page, hello from hello service and hello from service world. And if I put slash hello, you will get hello from hello service. And if I do world service, you will get hello from service world. So this was the complete video on how to design your repository and how to do the deployment with complete automation using Terraform and GitHub Actions. Thank you.